Okay, so let's proceed with homogeneous with constant coefficient. So as you can see here, so the lowest among the higher order differential equation would be the second order homogeneous equation. And as you can see here, so the given equation only involves the dependent variable y as well its derivative. In this case, that would be y prime and y double prime. So there are no other functions involved on the given equation aside from the dependent variable y as well as its derivative. Therefore, this given equation is considered to be a homogeneous equation. So in solving or in finding the solution of a second order differential equation, so we have three cases. Okay, so we have three cases. So depending on what kind of equation it is. Let's try first to determine, let's say, this given equation, y double prime plus y 5y prime plus 6y is equals to 0. And then we are to determine so whether the solution y is equals to e raised to negative 2x is really a solution of the given differential equation. So to do that, let's determine the first derivative. So y prime so would be equal to negative 2 e raised to negative 2x. And then the second derivative would be positive 4 e raised to negative 2x. Then we're just going to substitute it with the original equation. So we could see here that y double prime is 4 e raised to negative 2x. Then plus 5, y prime is negative 2 e raised to negative 2x. Then plus 6, e raised to negative 2x is equals to 0. So 4 e raised to negative 2x, then minus 10 e raised to negative 2x, plus 6 e raised to negative 2x is equals to 0. And 4 plus 6 is 10, minus 10 is 0. So 0 is equal to 0. And thus, y is equals to e raised to negative 2x is the solution of the differential equation. So this is what is unique with the exponential function. In a higher order differential equation, so most of the time, the solution is an exponential function. So one of which would be e raised to negative 2x. The idea there, it's because the exponential function, once you derive it, it's still an exponential function. Okay, the degree is still the same. The only difference is the numerical coefficient of the given function. So that is why in determining the solution of a first order differential equation, so usually the solution would look like this. So y is equals to e raised to mx. The only difference is just the coefficient m. And from there, so if we are going to substitute or find the first derivative, so that would be m e raised to mx. The second derivative, so m times m is m squared e raised to mx. And we're going to do the same thing. So we're going to substitute it with the original equation. So y double prime would be m squared e raised to mx, then plus 5y prime. So y prime is MEMX, so 5MEMX, and then plus 6 EMX is equals to 0. And as you can see here, e raised to mx is factorable, is common to all. So e raised to mx then multiplied with m squared plus 5m plus 6 is equals to 0. And from here, so since this is equated to 0, so this m squared plus 5m plus 6 so could be factored out. And once you factored it out, so that will be m plus 3 and m plus 2 is equals to 0. And thus our m sub 1 is negative 3, the other is negative 2. As you can see here, this is the negative 2 here, which is the first solution. So our first solution is e raised to negative 2x. And then our second solution would be the second root, which is negative 3, which is e raised to negative 3x. So those are the two solutions of the given second order differential equation. So that is why the first solution is e raised to negative 2x, second solution is e raised to negative 3x. And then, so applying the superposition theorem, so we could use or we could multiply the first solution by an arbitrary constant c sub 1 And then through the superposition theorem, so we're going to add the second solution times that of the arbitrary constant c sub 2. And thus our general solution then would be c sub 1 e raised to negative 2x plus c sub 2 e raised to negative 3x. So this is our first case. Okay, so case number 1, that would be the distinct roots. So for the distinct roots, that means the roots are not the same. Okay, totally the same. Even though they are the same in numerical value, but they are on opposite sign, that would still be considered as distinct roots. So distinct roots, so there is a difference between M1 and M2. So that is our first case. So in solving second order differential equation, as you can see here, so we're just going to transform. In this case, we're just going to transform the derivative into a power. So if it is y squared, so we're just going to make it m squared. Then plus 5 y prime, so first derivative, so that will be m. And then plus 6, so for the dependent variable only. And then that would be equal to 0. So afterwards, so we're just going to factor out. Or we're just going to, factor out and determine the roots. So once the roots are distinct roots, so we can use this given formula. So that is y is equals to c1 e raised to m sub 1x plus c2 is equals to e raised to m sub 2 of x, wherein the m sub 1 and the m sub 2 are the distinct roots of the given equation. So that is our first case. Our second case, so I'm just going to, okay, so this is our case 2. So for our case 2, that would be repeated roots. Okay, so that means they are exactly the same. M1 and M sub 2 are exactly the same. So possibly both are 3. So M1 is 3, M2 is 3. Possibly M1 is negative 5, M2 is negative 5. Okay, so as long as they are exactly the same, those are repeated roots. So actually, the repeated roots so uses a special method, the reduction of order. So I'm not going to discuss it anymore. So if you just want to know that, so just follow this lecture here. But in short, so this is the formula that we are using for repeated roots. So as you can see here, they are exactly the same. So C1, E1, C2, EM2X. The only difference is this. So we are appending X whenever there is a repetition on the roots. Okay, so we are appending X whenever there is a repetition on the roots. So for example, if M1 is 3 and M2 is 3, so for this, so the solution then would be y is equals to C1 x e raised to 3x plus C2 e raised to 3x. So that is to differentiate one solution from the other. So one has or appended, one is appended with x and the other one is just an exponential function. So it only follows that, for example, if it's a third order differential equation, so let's say we have m sub 3 here, m sub 3 is 3 as well, so there are, it's repeated roots, 3 times it was repeated. So our solution then, so would be, so we'll start with x squared. So C1 then, x squared e raised to 3x, and plus, so the power of x will drop, plus c sub 2, x e raised to 3x, and then lastly, plus c sub 3 e raised to 3x. So that is for the third order. So whenever we are repeating, okay, we are repeating the roots. So we are just going to append x, and then the power increases as well. So from 0, x raised to 0, which is 1, then x raised to 1, then x raised to 2. So if it's fourth order, x raised to 3. Fifth order, x raised to 4. So nag-start tayo, minus 1 lagi. Okay, so dun sa order ng differential equation. So that is for case number 2. So the thing here is we just need to factor out. Okay. So later on, I'll try to show you how to do it. So our case number 3, so this is our case number 3. So case 3 is, what if we have a complex roots? Okay. Remember that in finding the roots of second degree equation will yield into three different things. So possibly, so both are real numbers, okay, which are distinct. The other one is real number but repeated, and the last one is it's a complex number. Okay, the result is a complex number. Okay, so in a complex number, this is usually the roots. Okay, this is how it was expressed. A complex number comprises of a real number and an imaginary number. So the real part, okay, so which is the alpha, and then the imaginary part will be the beta. Okay, so real part is the alpha, imaginary part would be the beta. So it can be using quadratic equation, we'll be able to do that. So for example, we have these. So y double prime plus 2y prime plus 5y is equals to 0. So I'm just going to transform this one into an equivalent equation. Y double prime becomes m squared. 2y prime becomes 2m. Then 5y will become m. And then our new equation now, an algebraic equation, that would be m squared plus 2m plus m. So remember, we have a formula in finding the roots of a given equation, a quadratic equation. That's the quadratic formula. So applying this formula, and then simplifying, it will yield to a complex number. That is negative 1 plus and minus 2i. So we're in here, our alpha, okay, so alpha is negative 1, and then our beta is actually equal to positive or negative 2. Okay? So in that case, actually, hindi na natin kinukuha yung sign. So beta is always positive. Okay? So beta is always positive. So alpha, we're going to follow the sign of the real number. In that case, that's negative 1. In terms of beta, so beta would just be 2. Okay? Or it would just be the coefficient, okay, regardless of the sign. So ito lang yung derivation niya. Just follow it if you want to determine how it was derived. But on how to use the formula, it's just as simple as this. So once you know the roots, so at this given format, you have to determine which is alpha, which is beta. So alpha could be remember, alpha could be positive or negative. But beta is always positive. Okay, so beta is always positive. So that is why if we have negative 1 plus or minus 2i, then alpha is negative 1 and then beta is 2. So substitute mo lang dun sa formula natin. C1, E, alpha is negative 1, that is negative x. Cosine beta, beta is 2, cosine 2x. Then plus C sub 2, e raised to negative x, sine 2x. So in complex roots, so the roots are always in pair. Okay? So that is why if you have cosine, so definitely there will be a corresponding sign. Okay? So first root, yung sa cosine, the second root would be the sine. So those are the three cases that we have for homogeneous differential equation. So the only thing that we are concerned here is what would be the roots. So in determining the roots, so it could either be, we could factor it out, if it is factorable. If it is not factorable, so we can use the quadratic formula, if it is a second order. And then if it's, so definitely it could be solved using the quadratic formula. However, for higher order differential equations, so order 3 and above, so sometimes order 3 could still be factored out. However, if you can no longer factor it out, so we're just going to use trial and error. Okay, and that is on how to we're going to use synthetic division. Okay, so to determine the roots of the given differential, or the roots of the given equation. The roots of the given equation. Okay, so let's continue with examples on how do we find the solution of a higher order differential equation. So let's start with the second order differential equation. Example of which we have y double prime minus y prime minus 6y is equals to 0. So as our first step, so we're going to transform the differential equation into an equivalent algebraic equation. That is to change the second derivative into a second degree variable. So y double prime so becomes m squared minus y prime becomes m, and minus 6 is equals to 0. And then we're going to determine, so what will be the factor of m squared minus m minus 6. So will this be factorable? So I think so. So m squared is m and m, so the factor of 6 is 6 and 1. However, we need to get a negative 6, so it's a negative 6 and a positive 1, so negative 6, a negative 6m plus m. Oh, sorry, it's not 6 and 1. It should be a 3 and 2. So a 3 and a 2, so that would be a negative 6, and then negative 3m plus 2m is a negative 2. So that would be equal to 0. And from here, so we could have m sub 1 to be equal to positive 3, and then m sub 2 would be a negative 2. So those are the two roots. And as you can see here, so this is case 1, because those are two distinct roots. So for case 1, our general solution then so would be equal to our first solution, that is 3. So c1 e raised to 3x, and then minus c2 e raised to, or plus c2 e raised to negative 2x. So that would be our general solution. So c1 e raised to 3x, then c2 e raised to negative 2x. So this is case 1, distinct roots. Let's have, what else? Number 2. So y double prime plus 9y is equals to 0. So y double prime plus 9y is equals to 0. So this one would become m squared. Then 9y, so that would just be plus 9. So remember, we don't have, it's not 9m. As we don't have the first derivative. So it's only 9 then, it's equals to 0. And from here, so we could have m squared to be equal to negative 9. So m could be the square root. So m then would be the square root of negative 9. But remember, we don't have a square root of a negative number. So that would yield into a complex number. Okay, so that is the same as square root of 9 multiplied with negative 1. And the square root of 9, okay, the square root of 9 is positive and negative 3. Then square root of negative 1. But remember, the square root of negative 1 is equal to an imaginary number. So plus a negative 3i. So this is still a complex number. Okay, so since this is a complex number, since it involves an imaginary number, this one falls under case 3. That is a complex roots. But the difference with this one is that for our alpha and for our beta, so alpha is actually 0 and beta is positive 3. So remember, it does not have a real part. Okay, it only has an imaginary part, which is the 3i. It does not have a real part, so therefore that will be 0. And in determining the general solution, so that would be c sub 1, and then e raised to alpha, which is 0x, then cosine beta x, that is cosine 3x, then plus c sub 2, e raised to 0x, and then sine 3x. But e raised to 0x, that is 1. E raised to 0x, that is 1 as well. So therefore, our general solution then, so will just be c sub 1 cosine 3x plus c sub 2 sine 3x. So that would be our general solution. So y is equals to c sub 1 cosine 3x plus c sub 2 sine 3x naman. So let's have another one. So y double prime minus 10y prime plus 25y is equals to 0. So transform this into an equation, algebraic equation. So m squared minus 10m plus 25 is equals to 0. And I think this is factorable. So m squared would be m and m. So 25, the factor of which it will yield to a 10, would be a 5 and a 5. So that would be a negative and a negative. So negative, positive 25, negative 5m, and negative 5m would be negative 10m. So therefore, m1 is equals to m2. And that would be equal to positive 5. So those are distinct roots. Those are repeated roots. So repeated roots falls under case number 2. So falls under case number 2. And thus our general solution then so will be C1. And then since this is a repeated root, it is a second order, so we'll start with x. And then e raised to 5x. Then plus C2, e raised to 5x. So, ang difference na lang dun sa pangalawa, meron siyang x. So because it is a repeated root. So under case number 2. So you can see here, so these are the difference. So this is a case 1. So those are two distinct roots. So we're just going to simply change the exponent of the exponential function. So for the second example, that is case 3. It's complex roots. So we just need to determine the alpha and the beta and substitute it. So with our general solution, so yielding our answer there. And lastly, so for repeated roots, so which is under case 2, so we are just appending x. So tanggalin mo ang x, they are just the same. But we're multiplying x, okay, so to make it different, okay, so with the other solution. So that is for number 3. What if, so this is second order, right? So what if I have a third order, y triple prime minus y is equals to 0. So y triple prime is m cubed, then y, so would just be 1. Okay, so m cubed minus 1. Okay, so m cubed minus 1. So from here, so m cubed then would be equal to 1. And that will be, so m then would be cube root of 1. So cube root of 1, so would be still 1. Right? Our m1 then, our m2, and our m3 are all equal to 1. So since this is a repeated roots, okay, so it's repeated roots, but it was repeated 3 times. Okay, so for the solution, of it, so y then would be C1. So since this is a third order, so we'll start with an order 2, order degree 2 for x. So x squared, okay, a raised to, ang m natin is 1, so a raised to x, plus C2. So magti-drop down lang yung power. So magiging x na lang and then e raised to x. Then plus C3. Actually, that would be x raised to 0. Yung last. Kaya lang x raised to 0 is 1. So that would just be C3 e raised to x. And that would be the solution then. So C1, x squared e raised to x plus C2, x e raised to x plus C3 e raised to x. That is on how to find the roots. Okay, so that's on how to find the roots. So ito, puro pa factorable yung mga ano, no? Yung mga given. So what if it's no longer factorable? Y triple prime minus 5y double prime plus 3y plus 9y is equals to 0. So transform this one into an algebraic equation. M cubed minus 5m squared blend plus 3m plus 9 is equals to 0. So can we factor this out? I don't think so that this is factorable. Pero if it is not factorable, okay, so we can use synthetic division, no? We just need to try, okay, through trial and error, one of the roots, so to reduce the degree of the given equation. Pero kung pwede naman sa calculator, so pwede rin. So let's try calculator first. For example, I want to do it on a calculator. So yun, magmo-mode lang ako. Tapos ayun, third order. Ayan pala, naka third order na siya. I'm just going to clear it. So sabi niya, so that would be 1. Sa calculator, I think that would be mode 5. So for third order, mode 5-3, if I'm not mistaken. And then, kunin mo lang yung coefficient. That's negative 5, yung isa negative 5. Tapos positive 3. Tapos ang isa is positive 9. So 1, negative 5, 3, and positive 9. So you can see there, so the first root is negative 1. Okay. So first root is negative 1. Second root is positive 3. And then the third root, okay, it did not show. Okay, so dalawa lang ang pinakita niya. Pero actually, in reality, tatlo yan. Okay, so that is a third degree equation. So ngayon, para ma-verify natin whether these are really a solution or these are really roots, okay? So magsi-synthetic division lang tayo. So sa synthetic division, so I'm just going to get the numerical coefficient. That is 1, a negative 5, a positive 3, and a positive 9. Okay? So remember that the in synthetic division, so to determine whether that is root or not, the remainder should be 0. If the remainder is 0, therefore that is a root. If it is not 0, therefore that is not one of the roots. So in this case, so one of the root is negative 1. So in synthetic division, the first term, we're just going to bring it down. So 1, and then multiply it. 1 times negative 1 is negative 1. Then, so both are negative. So that would be negative 6. And negative 6 times negative 1, that would be positive 6. And 6 plus 3 is 9. 9 times negative 1 is negative 9. As you can see here, the last number would be the remainder, so which is 0. So therefore, if that is 0, that is already a solution, or that's a root of the equation. So in here, so marireduce na yan to. So kung babalik natin siya dun sa algebraic equation, so that will become m, then m squared. Kasi from 3, so since nakuha na isang first root, marireduce na yung degree from 3 to 2. So it will become m squared minus 6m and then plus 9 is equals to 0. So when one of the root is negative 1. One of the root is negative 1, so yung equation mo niyan, marireduce na siya into a quadratic. So pwede mo na actually i-factor. Pero let's proceed with our synthetic division. So another root is 3 daw. So kung 3 naman yan, so bring down 1. 1 times 3 is 3. Negative 6 times 3 is negative 3. Negative 3 times 3 is negative 9. So negative 9 and 9, 0. So okay na naman ulit tayo. Okay? So making it this time around, so that would be m and then minus 3 is equals to 0. So based from that equation, so obviously, our third root would still be positive 3. So bring down 1, then positive 3, that would be 0. So in short, yung isa is another 3. So what can you see here? So 1, the first root is negative 1. The second root and the third root are again the same. So which is 3 and 3. So to write the general solution then, so y would be, so parang it's a combination of two cases na, no? So it's a combination of the case 1, so which is a distinct root, and the other one naman is a case 2, which is repeated roots. So kapag sinulat natin ang solution nito, so that would be for the first root, that is c1 e raised to negative x. At sa pangalawa natin, c sub 2, so e raised to 3x. Yung isa, c sub 3, e raised to 3x. So since dalawa yung nag-repeat, okay, so dapat ang isa merong x. Okay, so since dalawa yung nag-repeat, so yung isa nun merong x. Tapos yung isa wala. Okay. So that will be our general solution. So c sub 1 e raised to negative x plus c sub 2 x e raised to 3x plus c sub 3 e raised to 3x. Okay, so that is for a third order differential equation. The number, let's have another one. Number 6. So, paano kapag ganito siya? So we have a third derivative of x with respect to t minus second derivative of x with respect to t, and then minus 4x is equals to 0. So how do we find the solution of the differential equation? So ito notation lang yung difference, no? Pero this is still the same. So palitan mo lang. So this is m cubed minus m squared. And then minus 1 equals to 0. Okay, so m cubed minus m squared minus 1 is equals to 0. So how do we find? So eto, kung magsisynthetic division tayo, let's say wala kang calculator, so magta-trial and error tayo. So mayroon yan dito, that would be 1, negative 1. Kaya lang we have to complete. So we have to complete all the terms. On the given equation kasi wala yung m. So since walang m, so that would be 0, and then the constant would be negative 1. So 1, negative 1, 0, and negative 1. 1, negative 1, 0, and negative 1. Since manghuhula lang ako, I do not know kung ano yung mga roots. Usually, nag-start ako sa positive 1. And then, nag-i-increase na lang ako. And bring down 1. 1 times 1 is negative 1. Times 1 is negative 1. Or 1 times 1 is positive 1. Sorry. It's positive 1. And then that would become 0. 0 times 1 is 0. 0 is 0, 0. But of course, this is 0. 0 times positive 1 would be 0, then negative 1. So, it shows na hindi roots yung positive 1. Yeah? So, since hindi siya root, so we have to change our trial. So, ano kaya ang pwede nating itry? Ayun. Ito na ang problema dito. Okay? So, the problem with this is the roots are not actually integers. Okay? So, the roots are not integers. So, let's check it on our calculator. So, kasi sa calculator natin, so sabi niya, the cube. Ay, sorry. That should be 4. So, this should be 4. So, negative 4. So, 1, negative 1, 0, and negative 4. Ayun. So, it's negative 4. So, pwede we could try 2. No? So, kung 2 naman, so bring down 1. 2. 1 times 2 is 2. So, negative 1 plus 2 is 1. 1 times 2 is 2. So, 0 plus 2 is 2. So, 2 times 2 is 4. So, making it 0. So, this sabihin, so we already have m sub 1 which is positive 2. And then from here, so this is the same as m squared plus m plus 2 is equals to 0. So, m squared plus m plus 2 is equals to 0. And as you can see here, so the only factor of 2 is 2 and 1. However, there's no such way that we'll be able to get m in the middle term. Okay? So, we could just use quadratic formula. So, kung gusto mo, gamit ka rin ng calculator. Okay, so quadratic, mode 5, 3, if I'm not mistaken, for quadratic. M112. So we could use yung calculator na lang siguro, no? So I'll go to mode, and then, ayan, quadratic. So it's 1, 1, and 2. 1 and 2. So, ayun siya, no? Square root of 7 minus 1 over 2. At saka yung negative I over... sorry, no. It's negative 1/2 minus square root of 7 over 2i. Let me do it on my calculator. So it's 1, 1, and 2. Yun, negative 1/2. Negative 1/2 minus... Tama. Ito ba sa calculator ko? 1, 1, and 2. My calculator, the answer would be M2 and M3. That would be negative 1/2. Yeah, it's positive negative. Square root of 7 over 2i. So kaya ang alpha natin dito, it's negative 1/2. Tapos ang beta natin is the square root of 7 over 2. So kaya ang solution natin yan, so we'll start with M1, that is C1 e raised to 2x. And then alpha and beta, so that would be for case 3. So that would be plus C2 e raised to negative 1/2 x, then cosine square root of 7 over 2. The variable that we are using is x and t. So, dapat x and t rin ang gagamitin natin. So, that would be x and t. So, 2t minus c2 negative 1/2 t, then cosine square root of 7 over 2t. Then plus C3 e raised to negative 1/2 t sine naman square root of 7 over 2t. So that will be our answer. Okay, so for a third order differential equation. Ito naman combination siya ng distinct root and case 3. Okay, so which is complex roots. Yung kanina kasi, it's distinct root and repeated roots. Okay? Nabibigay na yung mga different variations of the problem. No? Increase pa natin yung number 7. So let's have a fourth order. So y to the fourth, y fourth prime, at fourth prime, minus 2y double prime plus y is equals to 0. So this would be m to the fourth, minus 2m squared, and then plus 1 is equals to 0. M to the fourth minus 2m squared plus 1 is equals to 0. So I guess this one is factorable. So this is m to the fourth is m squared and m squared. And I could have a negative 1 and a negative 1 there. Negative 1 plus negative 1, so that would be negative 2m. Okay? And then, this is repeated. So m squared would be equal to 1, so therefore, m would be, okay, so the square root of 1, which is, I'll have m1 to be 1, and m2 would be negative 1. Pero the other one, it's still m squared minus 1, so therefore I'll have m3 to be equal to 1, and m4 to be equal to negative 1. So those are the four roots. So 1, negative 1, 1, and negative 1. Pero yung dalawa, repeated, then yung dalawa, repeated as well. So it's a combination of repeated roots. So our y then will become c1 x e raised to x tapos plus c2 e raised to x. So yun yung for m1 and m3. And then for m2 and m4, which is both negative 1, that would be plus c3x e raised to negative x plus c4 e raised to negative x. So that one will become, okay, so our general solution. Okay, so that's a fourth order. Let's have another one naman. Ito. y to the fourth derivative plus y triple prime plus y double prime is equals to 0. So this would be m to the fourth plus m cubed plus m squared is equals to 0. So m squared is factorable. I have m squared plus m squared plus m plus 1 is equals to 0. So from here, so magkaroon tayo ng m squared which is 0. So therefore, m would be the square root of 0. I'm sorry, it's still 0. So m1 is 0 and m2 is 0 as well. So m1 is 0, m2 is 0 as well. And then for the other one, the m squared plus m plus y is equals to 0. I think this is not factorable. If we're going to use our calculator, that is 1, 1, and 1. So by calculator na lang to, no? So by calcu. So ang m3 and m4 natin, that is equals to negative 1/2 plus and minus the square root of 3 all over 2i. So ang alpha natin yan, so will be negative 1/2. So beta is the square root of 3 over 2. So kaya magkaroon tayo ng solution. So ang solution natin, so this one, so 0 and 0. Okay, so 0 and 0 repeated roots, no? So we'll have c1, then x e raised to 0x, then plus c2 e raised to 0x. Then ito naman is in terms of case 3. So this one would become c3 e raised to negative 1/2 x cosine square root of 3 all over 2x, then plus c4 e raised to negative 1/2 x sine square root of 3 all over 2x. So rewriting this one, so e raised to 0 kasi is 1, this is 1 as well. Or in short, this one would be c1x plus c2 plus c3 e raised to negative 1/2 x cosine square root of 3 over 2x, then plus c4 e raised to negative 1/2 x sine square root of 3 all over 2x. So that will become our general solution. So for number 8. Okay, I'll have last example. So what if it is a fifth order? So we have d to the fifth derivative of u with respect to r plus 5 fourth derivative of u with respect to r and minus 2 third derivative of u with respect to r minus 10 second derivative of u with respect to r plus the first derivative of u with respect to r plus 5u is equals to 0. So ganun din, no? So m to the fifth plus 5m to the fourth minus 2 m cubed minus 10 m squared positive m and positive 5 is equals to 0. 1, 5, negative 2, negative 10, 1, then 5. So definitely, even on the calculator, so wala tayong ganito kataas na equation, no? Let me see, kahit dito, meron tayo, hanggang 4 lang ito, oh. Nakalock pa siya. The only way on how to do this is through trial and error. So using synthetic division. So kahit ako hindi ko alam ang roots, no? Manghuhula lang tayo. That would be 1, 5, a negative 2, negative 10, a 1, and a 5. So again, hula una is 1. So bring down 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. Negative 2 plus 6 is 4. 4 times 1 is 4. Negative 2 plus 4 is negative 6. Negative 6 times 1 is negative 6. That is plus negative 5. Negative 5. Ayun. So luckily, so we have m to be equal to positive 1. Let's have another one. So what if 1 again? So 1, so 1, 7, 7, 11, 11 times 1 is 11, positive 5. So 5 times 1, it's 5, 0. So therefore, ang M2 natin is 1 ulit. So, okay, may inuhula ko, no? So, what if, okay, one more. 1 pa ulit. So, 1, 1, 8. 8 times 1 is 8. So, I think this one will no longer work. So, lahat nag-i-increase siya, no? So, I'm just going to stop there. So, I'll do the negative 1. I'll have 1, a negative 1, 6, a negative 6, then a 5, and a negative 5. So 0. So M3 then would be negative 1. So this is already a second and I try another negative 1. So 1, negative 1, a 5, and a negative 5. So that is 0. So M4 is negative 1. And lastly, of course, so definitely, so this should be negative 5. So 1, a negative 5, a 0. So M to the 5th. Alright, 5th is 5th root, so negative 5. So yun na siya. So we have repeated roots, 1 and 1. Repeated roots, negative 1 and negative 1. And then M5, which is a distinct root of negative 5. So y then would be, so C1, it's 1, no? So x e raised to x plus C2 e raised to x. That is for m is equals to 1. And plus C3, x e raised to negative x, that is for negative 1. And plus C4, e raised to negative x. And lastly, plus C5, e raised to negative 5x. So that will be the general solution. And that's all for our examples.